Continuing with section 4.1, we are now going to look at an additional method to solving systems in addition to the graphical method. And the second method we're going to look at now is that of substitution. Substitution is pretty much what it sounds like. We are going to take out of our two equations, take the one equation that's easier to solve for one of the two variables involved, and then substitute what you solved it for into the other equation that would have been more difficult to solve for. That might sound a little confusing, but once you see a couple examples, I think you'll get the hang of it here. So looking at our first example of a system, 2x minus y equals 6, x equals y plus 2. So you want to look at the two equations and say, which one would be easier to solve for a variable? Doesn't matter if you have to solve it for y or for x. Either way is fine. And the second equation actually already is solved for a variable. It's solved for x, because the x is by itself. So because this equation, the second equation, is already solved for x, we want to then substitute. That's why we call this substitution. We want to substitute in what it equals. In this case, it equals the y plus 2. We want to substitute that into the other equation for x. Okay. So x equals this y plus 2. Well, then we take this y plus 2, and in the other equation, wherever we see an x, we're going to replace it with the y plus 2. So rewriting that first equation, we have 2 times x, 2x. So we're going to replace that x with the y plus 2. And then can just jot down whatever the rest of the equation had. Minus y equals 6. So what this did for us is it gave us an equation now that's in one variable. It's all in the variable y. We're not dealing with two variables anymore. So we can simplify this equation, combine like terms, get it down to a single y term, and then solve for y. So here the 2 we would have to distribute into this y plus 2 term. That's why I kept the y plus 2 in parentheses. So that's going to give us 2y plus 4 minus y equals 6. Okay. Combining our like terms, 2y here minus a single y leaves us with a single y, and we'd have y plus 4 equals 6, and then just subtract 4 from both sides. So the 4's cancel. 6 minus 4 gives us 2. So we get y equals 2 when we solve that equation for y. Now that only tells us half of our solution, because remember with these systems we need a ordered pair. So that gives us the y coordinate, but we need to find the x coordinate. So we can use that y coordinate of 2 and plug it into either equation, whichever one we think would be easier to then determine what the y, or to determine what the x coordinate would have to be for our solution. So we want to plug this y value of 2 into either equation. In this case, which would be easier to find the value of x? Well, looking at our second equation, since it's already solved for x, it'd be real easy. We can just plug in 2 for y here, and x is going to equal 2 plus 2. So I'll just write that in a little more detail, but since the equation we had was x equals y plus 2, okay, bringing this, we're going to plug it into that equation. Well, replacing the y with a 2, since we know the y coordinate has to be 2 at our solution, that gives us an x coordinate of 4. So for our solution, we have the ordered pair. Our x coordinate was 4. Our y coordinate was 2. So the ordered pair 4, 2. Their solution. We could check that by plugging it back into both equations. Okay, 4 does equal 2 plus 2. We know that one works. 2 times 4 is 8. 8 minus 2 gives us 6. So we would check. Okay. And even though our ordered pair were both integers, the reason why the substitution method is nice is when you would get answers that are fractions or decimals, because if we try to do that graphically, you wouldn't be able to tell where the solutions, where the two lines cross, if they crossed at like a decimal value. Substitution, you'd be able to find an answer that's a decimal or fraction value. So even though these are whole numbers, I guess the reason why we need a method like this is for when you have something that's a decimal or fraction. Alright, let's do this other example. We have, using the substitution method again, see if we can kind of really get this idea down. We have 3x plus y equals 10, and 6x plus 2y equals 8. Once again, we want to look at the two equations and determine which one would be easier to solve for one of the variables. And for me, looking at these two equations, I would say, well, when you have a y almost by itself in this first equation, we can solve this equation in just one move, getting the 3x to the other side. Okay. So the top equation, I would say, is easier to solve. We would have to subtract 3x from both sides, and that would get us y equals 10 minus 3x, or negative 3x plus 10, however you want to write that. So now we're going to use substitution. If y equals 10 minus 3x, we will take the 10 minus 3x and substitute it into the other equation wherever we see that y. So we need to rewrite that equation, replacing the y with 10 minus 3x. So we have 6x plus 2y, so replacing the y with 10 minus 3x equals 8. Okay. Distributing the 2 into that equation, or into that parentheses, we get 6x plus 2 times 10 gives us 20. 2 times a minus 3x gives us minus 6x equals 8. And actually now we can combine like terms. The 6x minus 6x will actually cancel each other out. So we don't even have an x term left when we combine those two. 6x minus 6x gives you 0. So all we have left is the statement that 20 equals 8. Well, if you recall, when we're solving just the basic equations, we get something like this that's clearly false. Okay, 20 doesn't equal 8. It's obviously a false statement. Okay, not true. If you remember from the basic equations, this means we're going to have no solution to this system. Okay, so our answer we could write is the null set. There is no solutions. So you could have that type of situation, you know, even with the substitution. That's how it would look when you're dealing with substitution. If we were to solve this system graphically, that would have been the situation where we had two graphs that don't cross each other, two parallel lines. So two parallel lines graphically would be the same thing as if you solve it by substitution and get a situation here, a statement that's false. And that's a pretty good idea of how substitution works. Next video we'll take a look at the third and last way to solve a system, and that is by elimination.